Lesson number 92 is about uniform motion problems about equal distances. Our first problem says, on Tuesday the express train made the trip in 12 hours. On Wednesday the freight train made the same trip in 16 hours. Find the rate of each train if the rate of the freight train was 15 kilometers per hour less than the rate of the express train. Now, what we know about these two trains is that they made the same trip. So if we were to draw a picture of this, we could show this like this. We could say the express train went this far in 12 hours, and the freight train went an equal distance. It just took the freight train 16 hours. So we've got 12 hours on top. We've got 16 hours on the bottom here. For our express train, we'll call that E, and our freight train is here. So they've got an equal distance. Now, what we know about distances is important because we know that distance is always equal to the rate that the object is moving times the time that it goes for. So if we were to say, for example, I was driving 50 miles per hour for 2 hours, well, 50 miles per hour for 2 hours must give us a distance of 100 miles. And this is the formula that we're going to use here in order to solve. Now, distance equals rate times time. We can shorten that to say d equals r times t. It's always nice to use abbreviations when we can. Now, what we know here, distance equals rate times time, and the key step to this problem is to do this. We know that the distance of the express train is going to equal the rate of the express train times the time of the express train. So let's say that. The rate of our express train times the time of our express train. That's the same thing as the distance. Well, if we also did that for our freight train, we could say the rate of the freight train times the time of the freight train. That's going to equal the distance of the freight train. We'll finish off that first equation by saying that's the distance of our express train. Now in this problem, we've seen the distances already. They're the same. So the distance of the express train equals the distance of the freight train. And another way to say that, another way we can say the exact same thing is to say the rate of the express train times the time of the express train is going to equal the rate of the freight train times the time of the freight train. And taking this step is the key part of solving this problem. Because what we know, we're given this information. The express train made the trip in 12 hours. So the time of the express train is 12 hours. We can write that here. T sub E, time of the express train, equals 12 hours. And then we're given that the time of the freight train was 16 hours. So time of the freight train equals 16 hours. Now what we're also given in this problem is that the rate of the freight train was 15 kilometers per hour less than the rate of the express train. So the rate of the freight train plus 15 is going to be equal to the rate of the express train. And once we get this written down, then we can solve our equation. Let's substitute values in. Time of the express train is 12 hours. Substitute in, please use parentheses. The rate of the express train here is the rate of the freight train plus 15. We'll put that in parentheses as well. Now we also know the time of the freight train. The time of the freight train is 16 hours. And then we have the rate of the freight train. That's the unknown. And it says find the rate of each train. Well, first we'll find the rate of the freight train. Then we'll find the rate of the express train by adding 15 to the rate of the freight train. Now, if you have to take a moment in order to write some of this down, please do, because I'm going to erase everything on the left-hand side so we have room to work. Okay, so if we rewrite that equation, the rate of the freight train plus 15, because that's the rate of the express train really, times 12 is equal to the rate of the freight train times 16. We can then go through here and find our answer. We're going to use a distributive property to say 12 times the rate of the freight train plus 15 times 12. 15 times 12, well, 15 times 10 if we work it out on the side, is 150. And 15 times 2 is 30. So if we put those together, 150 plus 30, we must get 180 equals the rate of the freight train times 16. I'm going to erase our side work. Then, as we continue through, well, we know we're going to subtract 12 times the rate of the freight train on both sides. Order of multiplication doesn't matter, so we're going to get 180 is equal to 16 minus 12, that's 4. So we're left with 4 times the rate of the freight train. Then we divide both sides by 4 in order to figure out what our rate of the freight train is. 180 divided by 4 must be 45. So 45 is equal to the rate of the freight train. Now, this must have a label, and it's got to be kilometers per hour. So the rate of the freight train, R sub F, equals 45, and you've got to have your label in there, kilometers per hour. You can write kph for kilometers per hour, and you'll get full credit for that. You could also write it all out if you would like. Now the second part of the problem, it said find the rate of each train. So now the rate of the express train. The rate of the express train was the rate of the freight train plus 15, if you remember that from earlier. The rate of the express train equals R sub F plus 15. You should have that in your notes. So the rate of the freight train was 45. So 45 plus 15 gives us our final answer of 60. So we've got the rate of the express train. That's equal to 60 kilometers per hour. And we've got both of our answers. We've got one more problem in today's lesson. Let's look at it carefully. The members of the girls' club hiked to Lake 10 at 2 miles per hour. Allie gave them a ride back home at 12 miles per hour. Find their hiking time if it was 5 hours longer than their riding time. How far was it to Lake 10? Now, we've got one of these uniform motion problems. The members of the girls' club hiked to Lake 10 at 2 miles per hour. So if they're hiking, it's going to take them longer than it will driving. And it said they got a ride back home at 12 miles per hour. So they went back home at 12 miles per hour. So you can see they go one distance and then they go back. But overall, it's the same distance that they've traveled. It's just the first time is to the lake and the second time is back home. So if we want to solve this, we need to know that formula. Distance is equal to rate times time. And then we know here the distance that they hiked, h, is equal to the distance that they rode, r, because they go there and back the same distance each time. So now we can use our formula. The rate of hiking times the time of hiking is going to be equal to the rate of riding times the time of riding. Just as a subnote, if you were still wondering why we use these subscripted variables, it really helps in these problems to keep everything organized. So, the members of the girls' club hiked to Lake 10 at 2 miles per hour. They hiked to Lake 10 at 2 miles per hour. That's their rate. So 2 miles per hour is their rate. We can write the t sub h in next because we're not given that. And then it said Allie gave them a ride back home at 12 miles per hour. So the rate of their ride was 12 times the time of their ride. Now we must have more information here. The information that we're looking for is where it says find their hiking time if it was 5 hours longer than their riding time. So the time of riding plus 5 hours is equal to their time of hiking, t sub h. Now we can substitute that into our equation in order to help us solve. Let's separate our work, because we've got t sub h equals t sub r plus 5. So we're going to get 2 times t sub r plus 5, because we substitute that in for t sub h, is equal to 12 times t sub r. Go through our multiplication here with our distributive property. You get 2 times t sub r plus 10 equals 12 times t sub r. And then we can go ahead and subtract 2 t sub r from both sides in order to find our answer. Now we have 10 is equal to 10 t sub r We'll divide both sides by 10, and t sub r, that must be equal to 10 divided by 10, which is 1. So, time of writing equals 1. We've got to have a label in there, so you could write it in here like this. 1 hour equals our time of writing. I'm going to make that a little bit more neat over here. The time of writing equals 1 hour, so it's easy to read. And it says find their hiking time. So if we want to find their hiking time, the time of riding plus 5 equals their time of hiking. So t sub h is going to equal 5 plus 1, which must be 6 hours. How far was it to Lake 10? Now that's our next question. We've got multiple questions that we've got to solve here. And if we want to solve our first problem, let's box it. How far was it to Lake 10? Well, in order to figure out how far it was to Lake 10, we know distance equals rate times time. So if we know the hiking time was 6 hours, and they go at 2 miles per hour, 6 times 2, distance equals rate times time. Distance to the lake equals 6 times 2. The distance must equal 12, and in this problem, it was miles. Now we could have used this formula as well with our riding time, because 12 times 1 hour, well, that's going to give us our answer of 12 miles as well. So you can use either the hiking time or the riding time in order to solve this problem. Our lesson practice is on page 386. Make sure you've got your notes complete, and I'll see you during our next class.